Hi everyone. In this video, I want to talk about what it is exactly that truth tables do. And what truth tables do is actually quite simple. There's one main thing that they're used for, and that is for any set of atomic statements, show you every single combination of truth values for those atomic statements. And then, on the basis of some rules, give you every single possible combination of truth values for some compound statement that's made up of those atomic statements. And what we're going to do in this video is we're going to look at an example, right? So that we can kind of sink our teeth into something in natural language English, right? We're going to symbolize that example. And then we're going to go ahead and look at a truth table piece by piece, right? So we can see exactly what it is that it does. And then I'll end the video by showing you some of the practical applications that truth tables can be used for. Okay, so let's go ahead and start off by looking at the example. So suppose that you're going to go, I don't know, you need to show some proof of identification, right, for something in the US, right? It's very common to have this sort of set of requirements. So I've written it down a little more simply, right? But basically, the requirement is something like you must bring either, right, your license and your social security, right? So you got to bring both of those things. Or alternatively, you can just bring your passport, right? So we're going to take our example statement to just be this set of conditions, right? Bring either, or I guess to put it in the form of a statement, one must bring either one's license and social security, or else just the passport will do. Okay, so that can be symbolized the way that I have here, right? So L for license, S for social security, and P for passport, right? And so what this shows is exactly what this says here, right? So either one brings both their license and social security, or otherwise one can just bring their passport. Okay, so now let's go ahead and look at exactly what it is the truth table is doing one step at a time. And we're going to go ahead and start with our atomic statements. Now, if you don't know how to set up a truth table, I have a video for that already. So you can just check that out first, and that'll tell you why it is that these truth values are ordered in the way that they are and what the significance of these different pieces is supposed to be, right? But okay, let's just go ahead and start off with these atomic statements. What exactly is it that this part of the truth table is doing? Well, it's grabbing every single atomic statement that we're concerned with. The order doesn't actually matter, right? It'll work all just the same, so it's arbitrary. I've just listed it out in the same order that it appears in the compound statement. And then what this is supposed to do is just list out every single combination of truth values, right, for these statements. Here's a nice way that I like to think about this. You can imagine that each row is just a possible world, right? A way the world could have been, right? So here in the first row, we have the world in which I brought all of my identification, right? So I brought my license, I brought my social security, and I brought my passport. You can imagine this final row as being the world in which I showed up completely unprepared, right? I didn't bring any of my forms of identification, right? No license, no social security card, no passport, right? And then you've got a bunch of options somewhere in between, right? So this is the world in which I brought my license and my social security, right? But I did not bring my passport. This is the world in which I brought only my social security card, right? And I didn't bring any other form of identification, and so on and so forth. And if you look down this list, you'll realize this is exhaustive, right? This covers every single possible combination of truth values, right? So every single world, right? All of the ways that the world could have been concerning specifically, right? These forms of identification are represented in this truth table. Okay, so that's the first step. The second step is actually the rules, right? And I've uploaded all of the videos for all of the logical connectives by the time that I've posted this, right? So if you want to know how it is that a truth table grabs inputs, right? So like let's say conjunction, right? So A and B or P and Q or whatever, right? Uh, if you want to know how it is that truth tables grab those truth values to spit out another truth value, go ahead and take a look at those, right? But for this video, I'll just assume that you already know all of this, right? Okay, so given these particular atomic statements, you have to use some rules, right, in order to know what it is that the truth table will calculate those out to be. Okay, step 3. This is the final step, right? Now all that's left to do is just to actually calculate that. Now notice, again, we have every single possible combination of inputs, right? Every single way, every single truth value that these 3 atomic statements could have. Now we're just going to go ahead and see what that actually gives us. Final point, right, before we actually calculate that. The way you want to calculate anything in a truth table is from the innermost parentheses all the way to the outermost, right? Whatever logical connective lies outside of any parentheses, that's going to be your main connective, and that's the one that you want to calculate last. Not just because that's what you want to do, but because that's the only way to do it, right? So this or depends on first knowing what the value of this conjunction is before you can know anything about what the value of this disjunction is going to be. So we have to start inside of the parentheses, right? In the innermost parentheses. So more complicated atomic statements might have a bunch of nested parentheses. You always have to start in the innermost parentheses and work your way out all the way to the main connective, which is the one that won't be wrapped in any parentheses. Okay, so let's go ahead and actually just calculate this thing, right? So L and S. L and S computes to true. We'll start off at the top, right? If both are true, otherwise it computes to false, right? So here L and S are both true, and I'll try to keep these nice and neat. So that's true. Here they're both true again, all right? So true and true gives true. True and false gives false. True and false gives false. False and true gives false. False and true gives false. False and false gives false. And false gives false. Right, so L and S are going to be true only in the first two rows, right? Because those are the only true rows in this truth table where they both have true truth values, okay? And now that we have that, we already have P, right? It's right there. So we can just calculate, right? So let's see. We know that a disjunction calculates to true, right? When either disjunct is true or both of them, right? And it calculates to false only when both of the disjuncts turn out to be false. So let's go ahead and see that. So true or true gives you true. True or false gives you true. False or true gives you true. False or false gives you false. False or true gives you true. False or false gives you false. False or true gives you true. And false or false gives you false. This is every single possible truth value of this compound statement. Here's another way of putting that. If these rows represent every single possibility, right, all of the ways that the world could have been, then this column here shows you what this whole statement would be in every single one of those possibilities, right? I'll phrase it yet again differently, right? So in the world in which you brought every single form of identification with you, you did the right thing, right? I mean, you may have gone a little overboard there, but the point is that whatever it is that you're trying to get, the government will give it to you, right? Assuming that all that's required is that you bring this identification, right? In the world in which you brought your license and your social security card, but failed to bring your passport, you're still in the clear, right? In the world in which you brought your license and your passport, but failed to bring your social security card, you are still in the clear, right? However, if you brought your license but failed to bring your social security card and failed to bring your passport, that's going to be a problem, right? That means that you failed the condition. In the world in which you failed to bring your license, but you brought your social security card and your passport, congratulations, right? You met the conditions. And that's exactly what this thing is expressing. In fact, if you just bring your passport, you should be in the clear, right? So what you need is either your license and social security card or your passport, right? Let's see if that's true. Bring your passport, you're good. 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 Every single scenario in which you brought your passport, you're in the clear. If you fail to bring your passport, you're going to have to bring both your license and your social security card in order to be in the clear. And that's the magic of truth tables, right? They show you every single possibility, every single combination of truth values in order to spit out all of the possible truth values for any given compound statement. Okay, so that's what truth tables do, right? That's really their one function. That is the one thing that they do, and they do it exceedingly well. But what can you use a truth table for? Well, given that truth tables can do this, you can use truth tables for all sorts of things, and I'm going to be uploading videos for all of that, just to list them out. Perhaps the function that you will most use truth tables for in an Introduction to Logic course is to test arguments for validity, right? And basically the way the truth tables do that is just by brute forcing it, right? It checks out what every single possible combination of truth values is for an argument, for every single statement in that argument, and then you can test, right now I'll show you how, on the basis of those truth values, whether the argument actually preserves truth, which is what a valid argument is supposed to do. You can also use truth tables to test whether a statement is a tautology, which is just a statement that's always true, whether it's a contradiction, which is a statement that's just always false, whether a set of statements is consistent or inconsistent, whether a pair of statements are logically equivalent, right? These things are really, really powerful. And in a much later video, I'll be covering, so you might have noticed that these things get really long, right? If there were 4 atomic statements, this thing would have 16 rows. If there were 5, it would have 32. So the good news is I will be covering in a future video how to construct what are called abbreviated truth tables. And those are truth tables that are actually much shorter. They're usually just 1, maybe 2, at most 3 rows. They require a little more thinking, but they're much quicker and much shorter, right? Which can save you a lot of space. Anyway, that's all I have for you today. So if you want to see more videos about logic or philosophy, stick around. I'll see you next time.